You fire a marble launcher horizontally from a height of 0.3 meters. The marble travels 1.2 meters before striking the ground. How fast was the marble moving when it left the launcher? As usual, we have our picture drawn. Here's our marble launcher. It's 0.3 meters above the ground. It's going to fire the marble horizontally with a particular velocity that we don't know. That's actually the question. And as always, everything in midair has an acceleration down, negative 9.8 meters per second squared. And it's going to land 1.2 meters away when it gets to the floor. So now we're going to pull our numbers out of the problem. I know going left and right in the x direction, I know D, it's in my drawing, 1.2 meters to the right is how far it's going to go. The velocity to the right is the question mark. How fast did it go when it was fired out of that gun or the marble launcher? In the y direction, I know the displacement in the y, it's down 0.3 meters, so that's going to be a negative 0.3 meters. The initial velocity in the y direction is 0 because this is horizontally launched. The acceleration, as I said, is negative 9.8 meters per second squared. We do not have enough information in the x direction to solve for velocity right away because we need the time in order to get that. So we're going to solve for time in the y direction and then use it in the x direction to get the thing that we really want. So here we're going to use the third kinematics equation because that's the one that does not have final velocity in it, because what we really want is time, so we can use it in the x. So d equals v naught t plus 1/2 a t squared. V naught is 0, which means 0 times t is going to cancel out, making our algebra just a little bit easier to do because that term is going to go away. So d equals 1/2 acceleration time squared. We're solving for time, so I'm going to get rid of the half and the a. To get rid of the half, instead of dividing by a half, I like to multiply by 2 because I don't like fractions in my denominator. But multiplying by 2 and dividing by a half is the same thing, so whatever your preference is, totally fine. So I'm going to put the 2 up in the numerator here and divide the a over to the left. That's going to equal t squared. But I don't want t squared. I got to get rid of that squared. So to get rid of a squared, you do the square root. Now everything is set up to solve for time, and that's what I'm going to do. I'm going to plug in my numbers. So 2 times d, which is negative 0.3 meters, divided by a, which is negative 9.8 meters per second squared, and all of that is under my square root symbol. When I plug in my numbers into my calculator, I get a time of 0.25 seconds for time. Now that I have time, I can go back to the x and solve for velocity. Our constant velocity equation is d equals v times t. Rearranging for velocity, I just have to divide time over. So d over t equals v. Plug in our numbers, and our horizontal displacement was 1.2 meters, and our time was 0.25 seconds. Plug that into my calculator, and I get that the velocity of this thing coming out of the gun or out of the marble launcher is 4.8 meters per second for speed.